All right, so we're going to start with this example. F of x is equal to x minus 1 divided by x plus 2. All right, so I want you to grab your calculator, and let's go to y equals, clear out whatever might be in there, and let's type this equation in y1. So remember that this fraction bar is also a grouping symbol. So you're going to type in parentheses x minus 1, close your parentheses, divided by parentheses x plus 2. The other way is you could make the fraction bar actually, come on your calculator with your math button. Let's take a look at that graph. So is the graph continuous or does it have a break in it? There's a break, right? It's not continuous would mean that you could draw the whole thing without ever lifting up your pencil. You see that this is in two parts. So there's what we call some discontinuity here. Do you see where that discontinuity happens on the x-axis? Right there at -2. So, why is that happening? We cannot divide by what number? We can never divide by 0. So do you see that if my denominator, x plus 2, cannot be 0, then that means x cannot be -2? And that is why we have this discontinuity right here at -2, because there is no x value at -2. So if I want to write the domain for this function, right, I've got two ways of writing it. Set notation, x such that, okay, my words and my writing is not going together. X such that x is an element of the real numbers and x does not equal -2. So set notation. But I can also write my domain in interval notation. I can say that my domain goes from -infinity to -2 with a parentheses, don't count the -2, and then union that with parentheses -2 to infinity. And when you're looking at your graph, you can kind of see that. So here's the domain for this portion of the graph, and then there's the break, and then here's the domain for the other portion of the graph. So the interval notation kind of shows you, here's interval 1, here's interval 2. All right, what about the range for this function? Look at the range going from bottom to top. Is there a break in the range? What y value does this function never equal? 1. So for my range, I could say all y's such that y is an element of the real numbers and y does not equal 1. Or if I put it in set notation, it would go from -infinity to 1, union with 1 to infinity. Set notation, interval notation. All right. But is this relation a function? Looking at the graph, does it pass the vertical line test? Yes. Would this pass a horizontal line test? So even though it looks like, well, Miss Collier, what if you draw it right there? This is going up ever so slightly, so it would pass a horizontal line test. Since it passes the horizontal line test, we know that the relation is in fact a function. The inverse relation is in fact a function. So we want to find what that function is. So, steps of finding a function. Step 1, we're going to take f of x and replace it with y. All right, and now we're going to start to find the inverse. So I'm changing colors to show that what I write down here is not equal to these equations. So I am going to now swap the x and the y. This is x equals y minus 1 over y plus 2. So swap, trade, exchange x and y. Once I've made that exchange, I want to solve for y. So what I really want to do is get y by itself. So when I say I'm solving for y, I'm getting y on one side of the equals and everything else on the other side of the equals. Well, in this situation, it's a little more complicated than some other problems because I have the y in two different places. So the first thing I'm going to want to do is eliminate having this fraction. So I'm going to bring everything down. And the way that I eliminate this fraction is by multiplying by the denominator. So since my denominator is y plus 2, I'm going to multiply by y plus 2. And I'm going to multiply by y plus 2 on the other side. Now, why did I want to do that? Because this way, when I multiply these fractions, this numerator and this denominator will divide into each other and give me 1. And now I will just have y minus 1. And then on this other side, I will distribute, and I will get xy plus 2x. Now, keep your end game in mind. We want to solve for y. We want to get y by itself. Right? I've got a y here, and now I've got another y over here. So this looks pretty complicated, doesn't it? Yeah. Well, what do you think we can do there? Even though I've got the y in two places, don't I want everything with the y on one side and everything with an x on the other side? Right? So, I want to make all my y's be over here. So I'm going to subtract y from both sides. And I want all my not y's to be on the right. So I'm also going to subtract 2x from both sides. You okay with me doing two steps at once? Again, I'm going for my goal, which is get all the y's on one side, get all the not y terms on another side. So now if I look on this side, 2x take away 2x, that's going to become 0. So this side is going to be xy minus y. And then on this other side, y minus y would be 0. So this side would be negative 2x minus 1. Doesn't look like we're making too much progress at a quick pace, but do we have all the y's on one side and all the non-y terms on another side? So we are headed in the right direction. But I'm still trying to isolate this y. I'm trying to get it by itself. So now this is a spot that a lot of people get to right here and they just get stuck and frozen. Do you see that we have a common factor of y? So right here we are going to factor out y. So remember, factoring out, you might think of it as undistributing. So now I have y times x minus 1 equals negative 2x minus 1. So now I'm going to divide both sides by x minus 1. And when I do that, the x minus 1 terms will divide out, and y will be by itself. And then I'll have negative 2x minus 1 divided by x minus 1. And now I can't divide these because multiplication comes before subtraction, so this is grouped together. So that's it. Now I just have one last step, which is to write it in function notation. F inverse of x equals negative 2x minus 1 divided by x minus 1 for, what do we have to say about the x? What can x not be?
1.
X cannot be 1. That domain restriction is a piece of your answer. You can't leave it out. Now, look back at this domain restriction compared with our original range. The range y could not be 1. This domain x cannot be 1. Because the range of your original function and the domain of your inverse function are going to be the same. Alright, there were a lot of steps there. Talk it out with a partner. If you did not understand any of those steps, please ask your partner to help you. Turn and talk.
Yes, I do.
Alright, my suggestion, as you're working and you get to spots and you start to feel stuck, always go back to, what is my goal? My goal is to get y by itself. Before that can happen, I have to get all the y's on one side and all the not y's on another side. If you keep your goal in mind, it will help you to progress. Alright, now grab your calculator. Alright, so now let's go back to our calculators, and let's go to y equals, and let's leave this in y1, and let's put our inverse in y2. So I'm going to have parentheses, negative 2x minus 1, close parentheses, divided by, parentheses, x minus 1, close parentheses, and I'm going to graph that guy. Alright, so let's take a look at our red graph. Do you see that our red graph has a discontinuity right here? Do you see why x cannot equal 1? Alright, now I'm going to go to y equals, and on this third line I'm just going to put y equals x. Do you see that if I reflect over the line y equals x, do you see how this red portion would flip over and be on top of the blue portion, and this blue portion would flip over and be over here on the red? Because inverses reflect over the line y equals x. So, let's say you did all this algebraically and then you graphed it, and what you graphed did not reflect over the line y equals x, that would tell you that something was wrong with your equation, right?
Maybe something is.
All right. Example 2. F of x is equal to 2 times the square root of x minus 1. So notice, that first example had a fraction in it. That was a rational function because we had a ratio, a fraction. This is different. Now we've got a square root function. So, can you take the square root of 0? Is that okay to do? Yes. If you're not sure about that answer, just try it on your calculator. Square root of 0 is 0. That's okay. But what about the square root of negative 1?
Nope. That's not possible.
Ah.
It's not a real answer, right? Square root of negative 1 is imaginary. And we'll be working with imaginary numbers in a little bit. But for right now, we're dealing with real number system. So, that means that what is under the square root, this x minus 1, has to be greater than or equal to 0. Because the square root of a negative is imaginary. So that means that x is going to have to be greater than or equal to 1. If I wanted to write this as my domain in interval notation, my domain would have a bracket at 1, and then it would go to infinity. Let's look at this guy's graph. Let's go to y equals. Clear this other stuff out of here. And let's put in 2 square root x minus 1. Oh, does it become very clear now that the domain goes from 1 to infinity? Right? Don't have any graph over here. So my domain goes from 1 to infinity. What about my range then? My y is greater than equal to 0. My range is going from 0 to infinity. Alright, so now let's do the algebraic steps. So first, I'm going to write this with y instead of f of x. And then I'm going to begin the process of writing my inverse. So I'm going to trade the x and the y. X equals 2 times the square root of y minus 1. So once I've made that exchange of variables, the equation I am working with is now the inverse equation. So I want to get y by itself. So I'm going to divide by 2. And I'll have x divided by 2 equals the square root of y minus 1. I want to undo a square root, so I'll square both sides. Square root and squaring undo each other, so this will just be y minus 1. If I do x divided by 2 squared, x times x is x squared, and 2 times 2 is 4. And then I'm just going to add 1 to both sides. So I have x squared over 4 plus 1 is equal to y. And then I will finally write it in function notation. Inverse of x is x squared over 4 plus 1. And if I just look at this, I go, oh, well, I'm not dividing by 0. I'm not taking any square roots. Maybe I think there's not supposed to be a restriction on the domain. But wait. The domain of the inverse has to be the same as the range of the original function. So even though there is nothing here that looks like it needs to be restricted, there is. Since this range is restricted, this domain has to be for x greater than or equal to 0. Let's go to the graph, and I think it'll become obvious to you why this has to be true. Let's type this guy in y2. I got x squared plus, divided by 4 plus 1. Alright, so that function is continuous, right? It's a parabola, a quadratic function. The plus 1, that's plus k, that caused a vertical shift. This is like 1/4, that caused a compression. Do you see that parabola is wider than usual? But if I come into here and I draw y equals x, so think about reflecting. Alright, well, if I reflect this part of the red, it would reflect on that blue. If you reflect this part of the red, flip it over, is there any blue down there for it to match with? So that's why this part can't be counted. Right? This portion of the graph can't be counted in the inverse, because there's no blue part over here to reflect it with. So we have to say, hey, here's the graph, but only this part of the graph, only the part of the graph where x is greater than or equal to 0. We're not going to count this part. All right, talk to your partner about this example. Does that make sense to you?
My physics teacher, I felt like I didn't have to. So, but
No, I forgot.
she has to taking the quiz today. Yeah. She told me so I go out.
All right, guys, some of you are hopping on your phone in between everything we do. That is not good for your brain. Right? Every time your brain is getting distracted, and you need to maintain your focus. All right, so you are going to try these two problems. Talk with your partners. F of x equals the square root of x plus 8, and g of x equals 6x plus 3 divided by x minus 8. Find your inverses.
Why do I keep falling?
That's still recording.
All right. Put the lights on. Let's just 2 out. Oh,
That doesn't.
sorry, you can't hear. Leave the lights off for a minute. Evan, let's write this down.
I'm supposed to go already.
Leslie.
That's all energy I have to do. I'm able to just. I've used up so much my energy to remember this. Could barely even stay awake. The little one is just thinking.
Alright, if you have not done this already, graph your function and your answer on the calculator. Check and see, does it reflect over the line y equals x?
Because I could be able to
Alright, let's check your answers. For number 1, f inverse of x should be x squared minus 8 for x greater than or equal to 0. For the second one, f inverse of x should equal 8x plus 3 divided by x minus 6, and x should not equal 6. So let me try and zoom out a little bit so you can check your steps along the way.
find out completely wrong.
Alright, what questions do you have about these? Where'd you get stuck? Yes, Lauren?
Can you go over how x does not equal 6?
Okay, so in this case, it doesn't have to do with the range of this. I mean, finding the range of your initial one is kind of hard, but look at your function here. We can't divide by 0, right? So if x was 6, 6 minus 6 would be 0. We can't have that. So the two main things to remember are, you can't divide by 0, you can't take the square root of negatives.
I don't understand that step. The one where you're doing go up one, that one.
Okay. So what I did here, and I was combining steps. So at this point right here, I'm saying, I want all my terms that have a y to be on the left, and I want all my terms that don't have a y to be on the right. So I added 8x to move this guy, and then I subtracted 6y to move this guy. And I just did them both at the
So
same
it's
time.
technically doing the same equation on both sides, but they're written backwards. Like 6 is in front, and then it's 8. Then the other one's 8, and then 6. But it's the same thing.
All right. So T brought up a point. She's like, it looks like it's the same thing, but it's backwards. So remember what an inverse is doing. An inverse is undoing the other function, right? An inverse means to undo. Like on your DVD player, your DVR, if you go fast forward 30 seconds and then you go rewind 30 seconds, you'll get back to the same spot, right? That's what inverses do. So, yes, if that function has multiplying by 6, this one is somehow going to have 6 in the denominator for division. That one, but the thing is, you can't just look at it and go, oh, I'm just going to flip this around because of your order of operations, right? So you have to really pay attention to the order of operations with it. But yes, that part is definitely going to happen. If something is multiplying in your first function, then that number is going to be doing division somehow in your second function. Other questions? All right. We are now going to switch to a related but different thing, which is to prove that two functions are inverses. So, what you were doing so far was, here's a function, you find the inverse. Now I'm going to say, here's two functions, I'm telling you I think they're inverses, you prove that that's true. Right? You remember when we had to prove trig identities? So proving the trig identity was not the same as solving the equation. Like, it was related, but it was not exactly the same. Alright, so I'm going to actually stop this recording.